Have you ever wondered if your computer gets heavier as you download more files, stream videos, or store thousands of photos? It seems logical that adding gigabytes of data should add physical weight to your hard drive. But this common assumption reveals a fascinating misunderstanding about how digital storage actually works. Traditional hard drives store information using magnetic fields on spinning metal platters coated with ferromagnetic material. When you save a file, tiny magnetic domains flip their orientation to represent binary data as ones and zeros. These magnetic state changes occur without adding or removing any physical matter from the drive itself. Solid-state drives operate on an entirely different principle, trapping electrons in floating gate transistors within flash memory cells. Writing data involves moving electrons from one location to another within the existing silicon structure. Since electrons have mass approximately 1,836 times smaller than protons, even billions of trapped electrons contribute negligible weight change. Early computers like the 1946 ENIAC used vacuum tubes and mechanical switches, where data storage physically altered hardware components. However, modern digital storage evolved specifically to manipulate energy states rather than physical matter, making data storage incredibly efficient and compact. Dr. John Kubiatovich from UC Berkeley calculated that storing data on a 4 GB Kindle would theoretically increase its weight by approximately 1 attogram, a number so infinitesimally small that no scale on Earth could detect it. This weight change equals roughly 1/1,000,000th of the mass of a single DNA molecule. To put this in perspective, the weight difference between an empty and full hard drive is comparable to the difference between a car, with or without a single photon of light inside it. The magnetic energy required to flip domains represents such minimal mass energy conversion that Einstein's EMC equation shows the effect is essentially zero. When you delete files, you're not removing physical matter, you're simply marking those magnetic domains as available for rewriting. The actual magnetic patterns remain until overwritten by new data. This explains why data recovery is possible even after deletion, as the physical magnetic states persist unchanged. Scientific measurements using atomic force microscopy have confirmed that magnetic data storage involves rearranging existing atoms rather than adding new ones. The energy difference between magnetic states is measured in electron volts, corresponding to mass changes of approximately 10 to the negative 36th kilograms per bit. Modern data centers storing exabytes of information weigh the same whether their drives are empty or completely full. The physical infrastructure, cooling systems, and power consumption remain constant regardless of data volume. Only the electromagnetic field patterns within the storage media change. Understanding that digital data has no meaningful weight helps explain why cloud storage and modern computing are possible. Your hard drive remains the same weight whether it contains vacation photos or remains completely empty. The magic lies in manipulating energy states within matter, not adding matter itself.
Thank you for watching. Please like and subscribe.